Hello and thank you for watching the second lesson of chapter 1, which is 1.2 frame forwarding. In this lesson you will learn about switches CAM table, content addressable memory table, also known as MAC address table, and what information switches use to build this table and forward the frames. In this lesson you will also learn about frame forwarding methods that we have. For this lesson I'm going to jump straight to our packet tracer that we were using in the previous lesson, and we're going to start learning how does the switch build this CAM table. But before we do that, let's look at the switch's predecessor, which was a hub. How did that device use to forward the frames? Right, so I'm going to build a network. So click on the networking devices, select a hub, and bring it in our workspace. And I'm just going to grab one PC, right, and do a configuration on this PC. And I'll show you a quick method that you can just copy and paste for the next PCs rather than do all this configuration. So I'm just going to give an IP address 10.1.1.10, 255.255.255.0, and gateway 10.1.1.1.1. Okay. Now, without me actually bringing another PC and do the same thing, what I can do, I can just highlight this PC, Control C and Control V. That will create another copy. So let's just create 4 of these, yeah? Right. All the configuration will be there. So all we need to do is just change the host portion of the address. So .20 here. That'll be easy. .30 here. So they open it on the other screen. .30 and the next one .40. So this is going to be the 40. Okay. On the name here, I'm just going to change this to 10.1.1.10. That's the name. So we know what's the IP address of the PC. And this is .20. And this is .30. And this is .40. Now the name doesn't really matter. You know, you can call it whatever you want. Right. There we go. We got 4 PCs with IP addresses there. And we're going to connect these one to a hub with a straight through cable. So click. And hub, you should know that this device works at layer 1 of the OSI model, and it doesn't have any CAM table or anything. What it's going to do is, as soon as it receives a frame from any of the devices, all it will do, it will regenerate that frame and it will replicate it. So what we're going to do, we're going to ping from this device, we're going to ping it to this device, this from source to destination. And as all the frames as they're coming in to the switch, sorry, to the hub will replicate them and it will send them. It doesn't look anything, so it doesn't read any information. It will just replicate them to every other device apart from the device they came in. So it won't send it back this way, but it will send it to every other device. Yeah. Now that's what the hub will do. Okay, let's just move these so we can see them nicely. Right. There we go. Okay, so if I go to this PC and sorry, it's always going on this side. And if I just ping, for example, let me just move here and say ping 10.1.1.40. I think we said the 40 was the previous one, yeah? So let's go here. Right. So we ping in from here, we ping in this device here. So from PC 10.1.1.10, we ping in 10.1.1.40, which is this one here. And I will go to simulation mode. And what I want to do is I want to get rid of all these packets. So filter, and I just want to see the pings, yeah? So I want to see the ICMPs. So ICMPs, and okay. So you should say here, you see the filter is just ICMP. And let me go there. There we go. Okay. Now when I press enter, the data is going to come from this PC. It's going to go to the hub, and then hub is going to replicate it. It's going to send it to every device, apart from the device that came in. All right. So if I press play, so now the hub, what is going to do? If I just go do this play, you see the hub is just replicating it, send it everywhere, apart from the data when it is a port they came in. So now I stop that, and you can see Instead of sending it that way, it will just replicate it and send it to every port, yeah? So play, you see? And these two devices are getting bothered for no reason, right? So that's what the hub is doing. So as soon as the packet arrives, regenerate the packet and flood it. Flood it to every port. Every port, apart from the port they came in. So that's the hub. Not very popular device in the networking today, right? Okay. So the next thing what we're gonna do is actually I'm gonna go to real time again. And again, like I showed you before, I can just copy, Control C, and Control V. I got same network as I had earlier. But on this network now, what I'm going to do is I'm going to delete this hub and I'm going to replace it with a switch. So I get a switch and a switch here and connect them. So I'll connect this to, doesn't matter what port really, say port 24, this one here. And this one is going to be port, say 23. I could connect them to any port, doesn't really matter. 22 and 21. Right. Now if I go to, for example, let's just wait for these to go green. And the reason why they're amber is because the switch is actually making sure there is no loop. It's having a loop prevention check, making sure that there's no loop in topology, then they will go green, which will be about 30 seconds here. See, this one is already gone green here, right? Now the switches, they won't behave like a hub. Once the frame comes in on the switch, so as soon as the frame comes in at the switch has something called CAM table, Content Addressable Memory Table. And in there, we're going to have the MAC address, the port number, VLAN ID, which we are not concerned with it right now, next lesson. As soon as the frame comes in, the switch will look at the source. Where is the source? And the MAC address of the source. So that's an IP address. We're going to put the MAC address here. Take the MAC address and stick it in the CAM table. Put the MAC address here and then put the port number. So port number 24, for example. And then look at the destination. Where is it going? Where is the destination? If the destination is on the table, it will forward it directly to the destination. If it's not on the table, it will flood it, same as what Hub was doing. It will send it to every port apart from the port they came in. So it will send it to every port apart from the port they came in. That is known as unknown unicast address. Unicast MAC address. MAC address. If the switch doesn't know the unicast MAC address, what port is it? It's gonna do something called flooding. Same as what Hub was doing. Flooding. A switch will also do for broadcast and multicast. If there's a multicast frame, we'll do, and broadcast will do flooding. Right. So the switches, for example, have this CAM table. So if I go to switch and to see the CAM table in the switch, I'll go to command line interface, right? And I'll do show MAC address table just to see what switch knows. So enable here, show MAC address table. And you can see this MAC address table on the switch is empty at the moment. The switch doesn't know any device, doesn't know any MAC address, doesn't know how he learns it, port, nothing. It's empty, the MAC address table. Okay, so what we're going to do is we're going to go to this PC and we're going to look at what MAC address does he have. So command line, and to find the MAC address was ipconfig /all to see what MAC address table we have. Okay, not table, what MAC address. So physical address of that PC is this. So let me copy that, right? And I'm just going to put it here. That's a physical address of this PC. So the switch, what it's going to do is going to take this MAC address. As soon as the frame hits the switch, it's going to take that MAC address. At the moment, just want to verify, we don't have anything yet. Okay, excellent. So now what we're going to do is I have an ICMP here that I can see it, but I want to also see the ARP messages, address resolution protocol messages. So those messages. So we see now ARP and ICMP. Now if I go to this machine and I'll do ping, I'm going to ping the PC up 10.1.1. if you want to see what this PC, what information has resolved, you do arp minus A. And this PC already knows the MAC address of the other PC, will not send ARP message. To clear this, ARP minus D, that will clear it. And now the PC doesn't know. So if I do ARP minus A, it doesn't know any entries. So when we ping this machine, it's going to send an ARP message first, and then it's going to forward the ICMP message. Okay, let's start again. So I go to this machine, and I'll do ping 10.1.1.40 and press enter. Now you should see two packets. One packet, first packet is ARP. This one is going to be ARP, Address Resolution Protocol, and this is a broadcast. And that's going to be like, it's going to ask everybody because it's a broadcast. When it hits the switch, we said that for the switch, it's going to flood that broadcast to every port they came in. But the switch first is going to look at the source MAC address. It's going to put it on his CAM table, and it's going to flood it. And then the device with the correct IP address will reply, and switch will look at the source MAC address and put it in his CAM table, right? And then send it directly to the PC 1 here, or 10.10 in the end. Okay, let's have a look. If I just clear this and just go to this PC and press go forward, that's the ARP message going to the switch. Now the switch has learned the MAC address of PC1 of .10. Yeah, so show MAC address. You can see that MAC address here. It's just been added. So this MAC address is just been added here because the frame is coming into the switch. Switch says, okay, I'll just take that MAC address, put it in that table, and I'll put this for 5 minutes. And then look at the destination. Destination is a broadcast because it's ARP. So because it's ARP, destination is going to forward to every port, right? Apart from, he's not going to send it back this way, but he's going to send it to every other port connected on the switch. But he's learned the MAC address of the source. So we learn it from the source. Okay, so if I press play, you can see now it's just going to send it to everyone. Now if we go to this PC and we're just going to take the MAC address of this PC, right? So if I bring this PC here, go to desktop and look at the MAC address table. MAC address. So IP config/all, and you can see the MAC address or the physical address. Let's just take the MAC address here. Control C. Oh, I can say copy, I think, and I'll paste it here. Right. Now this is the MAC address of this PC. This PC will create a reply and it will send it back. But the reply, the ARP reply, is going to be unicast, right? So the switch, if we look at the switching still, right? If we look at the switch, show MAC address table, you see the switch only knows of that PC MAC address. So when I reply, so send it back, now the switch will say, okay, I got a MAC address, source MAC address is this, right? Let me put that on my MAC table, and destination MAC address is this. I know exactly where the destination is, so I'm just going to forward it here, right? So if we look at the table of the switch, so if I repeat the command, show MAC address table, now the switch says, okay, well, I just got a frame with this MAC address, came to this port. So 9580, this MAC address, came on port 23, and the destination is this MAC address. So since I know where the destination is, I'm just going to send it directly there. I'm not going to flood it. So if he knows where the destination is, he's just going to send it directly. If it doesn't know where the destination is, it's just going to flood it. Yeah. Okay. So let's continue there. So he sends it directly. And then the next is just going to be the normal one-to-one communication. He's not going to flood it now because he knows the destination, he knows the source. So as soon as this guy gets a frame back to the switch, so he's getting a frame from 40, he adds another 5 minutes, sends it to PC.10. When he gets a frame from PC.10, it's going to add another 5 minutes. So it resets the counter. So the MAC address table is always going to be the counter. It's going to be 5 minutes here. All the information. But it doesn't know about these two IP, for example, the frame, like the MAC address of the .30 and .20 here. Okay, let's go. Let's clear this. So if I ping, so .10, then again the first is gonna, okay, it's an ICMP. So let's have a look. Okay, let's clear this. I go to real time and I want to ping the dot. I should have picked 20, right? So I'm gonna ping everything, yeah, 30 and 40. Okay. The other one I was pinging myself, yeah. So okay, this PC, if when this PC pings all of the PCs, so ping 10 1 10, ping 30, and ping 40. Okay. And this PC, let's ping from this PC. So now all the PCs, they have done the ARP, yeah. So that's what I'm doing. So ping 10.1.1.10, 20, and 40. Okay. Now all the PCs. So if I go to this PC and I'll do ARP minus A, you can see it knows the MAC address of .20 PC, it knows the MAC address of .30, and it knows the MAC address of .40. It knows all of them. As well as the switch has learned all of them now. So if I do show MAC address, now it knows all 4 PCs. The 21 MAC address, that's that one there. 22 MAC address, that's that one there. 23 MAC address, the one on the top. And 24 MAC address, the one underneath here. Right. So what we can do here, we can do clear MAC address table. Like if it was brand new switch. Now the switch doesn't know anything. The PCs knows the ARP table, but the switch doesn't, right? So when I send a unicast from this PC, I'm going to forward a unicast ICMP packet, not a broadcast, unicast. From here, this PC is going to send it from this source to this destination, for example. But the switch doesn't know where the destination is. So since the switch doesn't know where the destination is, it's going to take this, it's going to flood it. It's going to send it this way, it's going to send it this way, and it's going to send it this way until the destination replies. When the destination replies, then it will send it directly. It will just forward it here. So it won't flood it. Only when it doesn't know the destination, it will flood it, right? So if I go back to the switch, let's have a look. Still nothing. That's good. That's good. That's what you want. So if I go to simulation and go to this PC and ping, do ARP minus A, I still have that information, and I ping the 40. You see what's going to happen. Now this is a unicast. So if I press play, the switch will learn this MAC addresses, right? This source MAC address. So if I do show MAC address, now he's learned the 9A. But it doesn't know where the destination is. So since it doesn't know where the destination is, it floods it. Sends it to everywhere. Now when the .40 replies, the switch will learn that on its table. It will say, okay, well I got the MAC address of that one. And it will forward it directly to there. Right? Now I want you to pay attention. If I ping, for example, if I ping from here to here, the switch doesn't know. It knows this MAC address is on this port. But do you think it's going to send it this way as well or not? We said when the switch doesn't know the destination MAC address, it's going to flood it, yeah? So I'm going to ping the 30. Let's say 30 now. Right? And we'll see. Now the switch knows this MAC address, that's port 23, it knows there's something in there, yeah? So look, port 23, it knows the import 23, there's this MAC address. But here's pinging this PC's MAC address. So when the frame comes in, the switch will add another 5 minutes from 9A, but it doesn't know where this MAC address is, so it's going to flood it. Flooding means everywhere. Even the ports, they've got some information into them, right? So if I click play, look, the switch is going to flood it, right? Now when the PC replies, he's going to learn a .30's MAC address, yeah? So if I look here, see the 22 port, that's the MAC address of .30. Okay, it's going to forward it directly there. Now, if I ping this PC, the switch doesn't know what is connected on port 21. So it doesn't know port 21. So when I ping the port 21 from here, so ping which is 20, what do you think is going to happen? The switch doesn't know where this is. So when it goes to the switch adds another 5 minutes for this as a source, but it doesn't know where this is. So again, it will flood it. So it will flood every time there's a unknown unicast, broadcast, and multicast. And now it will learn it, the MAC address. As soon as there's a frame, it will learn the MAC address of the destination. There you go. Okay, so that's how the switch is learning, right? So we need to know the switch is actually learning the MAC address. We have ingress and destination address. As soon as there's a, for example, say that this is a source and this is a destination. So once the frame hits the port on the switch will learn the MAC address, will put it on this table with FA01, what VLAN is, for 5 minutes. Because the switch doesn't know the destination MAC address, it doesn't have it on the table, it's just going to flood it. It's going to send it this way, and it's going to send it this way. Now this PC is going to ignore it. It's going to say it's not for me. But this PC will become now the source with this MAC address, and this will be the destination. So now when the frame comes in on the switch will say, okay, well, you came on port 13. This is the source MAC address. Let me put that on the table. 5 minutes. And the destination is this. I know where the destination is, so I'm just going to send it directly to the destination. And then later on, it will learn about this PC as well. So the switches, they build the MAC address table through learning while examining the source MAC address. They learn it. If it's not on the table, they will add it on the table. If it's already in the table, they will put another 5 minutes. And they will forward, if the destination is on the table, they will forward it directly. If the destination is not on the table, they will forward it to all the ports, apart from the port they came in. They will not, they will flood them. It's called flooding, as well as for broadcast and multicast. Now there's two types of switches. We have a store and forward switch and cut through switches. Store and forward, they will take all the frame and they will store it in memory, right? Before they forward them. So they will store them there, making sure the CRC, once you compute the CRC, which is a frame check sequence, is correct. If that's valid, then they will forward. Store and forward switches, they will not forward any corrupted frames. While cut through, as soon as they read the destination MAC address, they will forward the frames. Okay, so store and forward switches, store and forward, they'll do the error checking, making sure they will calculate this frame check sequence before they forward it. So they will not forward any frames that has been corrupted. They can store up to 9,200 bytes for jumbo frames before they forward them. And because automatic buffering provide the flexibility to support any mix of Ethernet speeds. While cut-through switches, as soon as they read the destination MAC address, they will forward. Well, we have two cut-through switches. We have rapid frame forwarding. That is, as soon as we read the destination MAC address, we'll forward. We send them. But we're not checking the frame check sequence, which means that we could be forwarding corrupt data. Another type of cut-through is fragment free. Check the first 64 bytes, making sure that there is not being fragmented. The frame hasn't been fragmented. If the frame hasn't been fragmented, then we can forward it. again, we're not checking the frame check sequence because we just want speed. So both switches, this switch, the cut through switches, they could be forwarding corrupted frames, while store and forward doesn't forward corrupt frames. Now, both they have the advantages and disadvantages. For example, store and forward switch, with the disadvantage there will be it's just going to forward something. It's going to create that delays while they store in the frames, while cut through is fast forwarding the frames. But cut through could be forwarding corrupted frames. Thank you for watching lesson 1.2, frame forwarding. This is of chapter 1, basic device configuration. Please have a look at my other videos in YouTube channel and don't forget to subscribe there. This has been Astrid Krasniqi. Bye bye.